Good evening. We'll continue differentiation. First problem. If x is equal to a secant square theta, y is equal to a tan square theta, then d square y by dx square. We have asked d square y by dx square. So you can first cancel a. No need of a because when you divide, definitely it is going to get cancelled. Let us cancel the beginning itself. We want dy by dx. That is dy by d theta divided by dx by d theta. All these we are not writing. So overall imagine you differentiate tan square theta. That is chain rule 2 tan theta into secant square theta. You differentiate secant square theta. It is 2 secant square theta tan theta. Why secant square? Because 2 secant theta into secant tan theta. So you must write this directly. Everything cancel, you get 1. Therefore, d square by dx square is 0. So no need of writing even dy by dx. You can just write 2 tan theta into secant square theta. This is 2 secant tan theta. Both cancels, you get 1. The moment you get 1, second derivative is automatically 0. You can save some time there. Let's go to the next problem. If tan inverse of x square plus y square is equal to alpha, then what is dy by dx? Here you should understand, don't start differentiating tan inverse x is 1 over 1 plus x square and all that. You have to just, in the beginning itself, write this. X square plus y square equals tan alpha. X square difference is 2x. This is 2y dy by dx equals 0. 2 cancels. Dy by dx equal to minus x by y. Can complete in less than 1 minute if you are good in differentiation. Next problem. Derivative of cos inverse of 2x square minus 1 with respect to cos inverse. So all these time, or what we were doing all this time, we were differentiating with respect to x. But here we are not differentiating with respect to x, we are differentiating with respect to cos inverse x. So what is the chapter? Derivative of one function with respect to another function. It is something similar to parametric differentiation. So what we do is we put y is equal to cos inverse of 2x square minus 1 and z is equal to cos inverse x. Now read the problem. Derivative of cos inverse 2x square minus 1 with respect to cos inverse x. That means the derivative of y with respect to z. Therefore, we have to find dy by dz. Dy by dz. So what is dy by dz is equal to So here we have to find dy by dx and dz by dx and then divide one by the other. Inverse trigonometric function, you should realize what is the substitution. If you put x equals cos theta, if you put x equal, that you should know. The moment you see the problem, you should know that you have got to put cos theta because it is going to simplify. Cos inverse of 2 cos square theta minus 1. That is cos inverse of cos 2 theta. That is equal to 2 theta. So you have to differentiate 2 theta with respect to what is cos inverse x theta. If x is cos theta, theta is cos inverse x. So what is that you are doing? You are differentiating 2 theta with respect to theta. Therefore, answer is 2. You need not work. Even if you work, what you do is y is equal to 2 theta is 2 cos inverse x. Differentiation of cos inverse x with respect to cos inverse x is 1. How? Derivative of x with respect to x is 1. So there is no need of finding dz by dx. If they are given something other than cos inverse x, then you are supposed to substitute and do it. So the moment you see orally you can do it. This is cos 2 theta is cos inverse x. Therefore differentiating cos inverse 2 cos inverse x with respect to cos inverse x, that is nothing but difference of 2x with respect to x. That is 2. So these problems will give you little more ideas about differentiation. Next, find the derivative of sin square theta with respect to cos square theta. Same thing, you can call this as y, this as that. You have to find dy by dz. If you are good in calculus, you can get the answer -1 directly. Because yesterday I was talking about this. Derivative of cos square theta is minus sin 2 theta. Derivative of sin square theta is plus sin 2 theta. Both will cancel -1. Because the derivative of sin theta is sin square theta is 2 sin theta cos theta. That is sin 2 theta. Cos square theta 2 cos theta minus sin theta. So if you remember this. Sin square theta derivative is sin 2 theta. Cos square theta derivative is minus sin 2 theta. You get -1 as the answer. They have not asked, they have found find d square y by dx. That's the problem. Therefore, that is 0. Because you are getting 1, it's a constant, that is 0. The next problem, if y is equal to log t plus sin t, log t plus sin t, y is equal to e to the power of t plus cos t, then dy by dx. There is no skill, nothing, you have got to differentiate directly. So this is x is equal to, that is y is equal to. So you have to find dy by dx. Dy by dx is e to the power of t is e to the power of t only. Cos t is minus sin t. Log t is 1 over t plus cos t. They would not have given the answer like this. They would have simplified. T will come to numerator e to the power of t minus sin t over 1 plus t cos. This is the answer given in the book. 4 answers that are given. You have to just search for the answer and pick the right answer. There is no skill, there is no other method. Only thing is you should be good in differentiation. Okay. If you are good in differentiation, these problems appear very, very simple. The next problem. If xy is equal to c square, if xy is equal to c square, here I want to list the answers given. Then dy by dx equals. I want to write all the 4 answers. The first answer is c square x square The second answer is c square y square. The third answer is minus c square by x square. The fourth answer is minus c square by y square. Now, yesterday I was talking about this. The solutions will not be in the format that you get. So in such cases, you should look at the answers given and try to reduce that. That is one extra step. So here, if you differentiate this, you get derivative of x is 1, y plus x is 1, y you keep it as it is, y, that means you are keeping y and differentiating x, plus keep x and differentiate y, dy by dx is equal to 0. So dy by dx is going to be minus y by x square. That answer is not there. They have got c square. That means you have to bring in c. How to bring in c? What is y? Y is equal to c square by x. So the answer should be so this should be c square by x cube. So what happens is y is equal to c square by x divided by x square. Therefore minus c square by x cube is the answer. You got it? Try to understand the problem. You are getting minus y by x. Minus y by x. Therefore c square x square is there. This is minus y by x. What is y? Minus c square by x divided by x. So then there is no mistake in the solution. This is minus y by x. What is y? C square by x. And x will come down. So this is where some time is wasted if you are not able to realize this. This is where the examiners play a role. Remember, it is a very simple problem. We are looking for minus y by x. That answer is not at all there. So answer has to be, there should be, you can remove x also. In that case, y will come to the numerator. You can check that. But that answer will not be there. Therefore, this is the answer. Next problem. If x is equal to cos theta plus 1 plus cos theta. Cos theta plus 1 plus cos theta. Y is equal to sin theta plus 1 plus sin theta. Sin theta into 1 plus cos theta only. 1 plus cos theta. Then dy by dx at theta is equal to pi by 2. So let us find dy by dx. This is cos theta into 1 plus cos theta minus sin theta cos theta. Product rule, keep 1 plus cos theta as it is, differentiate sin theta by cos theta, keep sin theta as it is, this is 1 is 0, cos theta is minus sin theta, divided by, here again product rule, minus sin theta into 1 plus cos theta, keep cos theta as it is, so this is minus sin theta cos theta, no, minus sin theta cos theta. Don't go for any simplification. Theta is pi by 2. This is 0. This is also 0. This is also 0. What about this? Minus sin pi by 2. Oh, there is a small mistake here. Sin theta into this. Okay, no problem. Cos theta is 0. This is also 0. Therefore, this is 0. Here cos pi by 2 is 0. Sin pi by 2 is 1. So minus 0 by minus 1. Or total answer is 0. You can write the answer as 0. Some mistake we have done. Wait. When you keep 1 plus cos theta, okay. This is a mistake. Because the answer they have given minus 1. So here sin theta keep as it is. To differentiate cos theta, we get minus sin theta, therefore minus sin square theta. So the answer is minus 1 by 1, that is minus 1. This is minus 1, this is also minus 1. So the answer is plus 1. Because this is minus sin theta is there. This is minus 1, this is also minus 1. Sin pi by 2 is 1, cos pi by 2 is 0. So please make correction. We are differentiating using product rule. I keep 1 plus cos theta, differentiate sin theta, I get cos theta. I keep sin theta, differentiate cos theta, I get minus sin theta, sin square theta. You have to be a little careful in interpreting. Okay. The next problem. If y is equal to log of tan pi by 4 minus x by 2, then dy by dx equals, I will write the 4 answers given. The first answer is secant x. The second answer is minus secant x. The third answer is cosecant x. The fourth answer is minus cosecant x. Then why we should look at the answer? Because we are tempted to write the formula tan of pi by 4 minus theta is 1 minus tan theta over 1 plus tan theta. Then we may apply the formula log of a by b is log m. Log of a by m by n is log m minus log n. That should not be used because the answer is not in that simplification format. Therefore, the only method that we are going to employ is use chain rule. First, if you differentiate log, you get 1 over tan pi by 4 minus x by 2. Then you should differentiate tan, it is secant square pi by 4 minus x by 2. Then you should differentiate pi by 4, that is 0, x by 2 is minus half. You have to arrive at this answer. So what you can do is, you can write this as cos pi by 4 minus x by 2 divided by sin pi by 4 minus x by 2. Secant square is 1 over cos square pi by 4 minus x by 2. Minus sign here and bring this 2 here. This will cancel. So you should realize 2 sin A cos A is sin 2A. So this is minus 1 over sin 2A is sin of pi by 2 minus x. What is sin of 90 minus x? Cos x. So what is your answer? Minus secant x is the answer. So it should be good in chain rule. Differentiate log 1 over tan is secant square pi by, and some students forget this, very important. First log, then tan, then bracket inside. Pi by 4 is 0, x by 2. So this is 2 sin A cos A, 1 cos will cancel. 2 sin A cos sin 2A. So when you work the previous year's papers, these ideas you will get it. Otherwise, you are tempted to use the formula and log of 1 minus tan x 1 plus tan x by 2. That will take a long way and you may not get the solution. The next problem is y is equal to pi to the power of log sin x. What is, you should remember, if y is equal to pi to the power of x, what is dy by dx? It is pi to the power of x into log pi. So if you apply that formula, You get 5 to the power of log sin x into log 5. Then you differentiate log sin x, that is cot x. Would you get it so fast? Integration of cot x dx is log sin x. Sorry, it is minus log sin, therefore minus cot x. That's the answer. So, if you can realize log sin x will give you minus cot x. Because cot x, log sin x is going to be minus plus cot x only. Because we differentiate log sin x, you get 1 over sin, okay, this plus cot x only. So 5 to the power of log sin x into log 5 into cot x. They would have given that answer, you have to take that answer. I have not listed the answers. Okay, let's go to the next problem. So use the integration formulas and simplification becomes very easy. Differential log sin x is cot x because integration of cot x is log sin x. The next similar problem, y is equal to log of cosecant x minus cot x. Without working, you can take the answer as cosecant x. You know why? Integration of cosecant x is log of cosecant x minus cot x. So difference in the log of cosecant x minus cot x is cosecant x. So if you use the integration formula, you get the solution faster. The next problem they have given is y is equal to cos inverse of 2 cos x minus 3 sin x by root 30. These are all standard problems you should have worked in the exam classes, but the only thing is they can change the numbers. So here, what the method is, you should have worked earlier, that otherwise you can't work this in CET. You separate this 2 by root 13 cos x minus 3 by root 13 sin x. So if you take a triangle and adjacent side is 2, this is root 13. What is this? 13 minus 4 is 9. This is 3. So 3 by root 13 is sin t. This is sin x. So let us take this as theta. So the problem is going to be cos inverse of cos theta cos x minus sin theta sin x. It is nothing but cos inverse of cos of theta plus x. That is nothing but theta plus x. So dy by dx is going to be 1. Very simple problem, provided you are able to understand. You have to express like this. Even this is also not required. Orally you can do it. When it is 2 by 13, 13 square is root of 13 is 13 minus 4 is 9. 9 is 3. So 3 by root 13 is sine. And why should you take cos A cos B minus sin A sin B? Because cos inverse is there. Okay. The next problem, y is equal to log of tan x by 2. So what is dy by dx? It is 1 over tan x by 2 into secant square x by 2 into 1 by 2. First differentiate log, then differentiate tan, and x by 2 is 1 by 2. So this is again, we have already worked this problem. The cos will go up, sin will be there. Therefore, the answer is 1 over sin x. That is cosecant x. That is the answer given the examination. How 1 over sin x? You are writing this as cos x by 2 by sin x by 2. Bring this 2 here. This is 1 over cos square x by 2 One cos will cancel. 2 sin A cos A sin 2A. A you got to exploit the sin X answer is given as cosine. So these things you should be able to catch very fast. Where you can save few seconds, maybe 10 or 15 seconds. Add up all these 10 or 15 seconds, you get an extra time for a difficult problem. The next problem. If x is equal to a into 3 cos theta plus cos 3 theta, y is equal to a into 3 sin theta plus sin 3 theta. See, we can't use that formula. Sin 3 theta is equal to 3 sin theta minus 4 sin 3 theta. Can't be used because they have 3 sin theta plus sin theta. So it is not possible to use the formula. The only method is you have to differentiate. I've told you first thing you cancel A. Anyway, you are going to get cancelled later. dy by dx is equal to 3 sin theta is 3 cos theta plus 3 cos 3 theta divided by 3 cos theta is minus 3 sin theta minus 3 sin 3 theta. So you can cancel this. So this is cos c plus cos d. 2 cos c plus b by 2 cos c minus b by 2. This is minus and take it out. 2 sin 2 theta into cos theta. This will cancel. This will cancel. You get minus cos 2 theta as there. All these you should realize very, very fast. First cancelling A. Everywhere 3 is there, cancel that. There's a minus sign. When you take minus sign, it is cos sin c plus sin d. So for sin c plus sin d, first sign and then cos. For cos c plus cos d, first cos and then sin. For minus sin of cos c minus cos d, both are sin. Those things I have discussed in the earlier classes. Let's go further. Y is equal to cos of, very interesting problem, 2 sin inverse cos x. The first thing is if you had sin here, then sin inverse of sin theta is going to be theta. You could have worked out fast. So first you should remove this cos. How that idea you should get. How to remove that cos? You can write this as 2 theta directly if you can follow this. How? Oh, sorry, not 2 theta. You are writing cos x as sin of pi by 2 minus theta. Therefore, this is 2 pi minus 2 theta. Because this is going to be sin inverse of sin of pi by 2 minus theta. That is 2 into pi by 2 minus theta. That is pi minus theta. Pi minus 2 theta. So what is pi minus 2 theta? Cos of 180 minus theta is minus cos theta only, minus cos theta. Now the problem is not over. You should differentiate that. What's the derivative of this? Sorry, this is not theta, this is x. So you get minus cos 2x. Differentiation of this is 2 sin 2x. And a minus in get cancels. So I'll repeat once again. You need to convert this cos to sin. Sin of pi by 2 minus x. So you get 2 into pi by 2 minus 6, pi minus 2x. Cos of pi minus 2x minus cos 2x. Difference of minus cos 2x is plus 2 sin 2x. What is required is you have a very clear knowledge of differentiation. The next problem. Y is equal to tan inverse of 4x over 1 plus 5x square. These problems you should have worked earlier. Otherwise, it is not possible to work it out in CET. The only thing is, if it worked earlier, you can just do something. That means you can reduce some steps, that's all. If it not worked earlier, it is not possible. 1 to 2 plus 3x over 3 minus 2x. See, over 5x square. Should have worked this problem earlier. We can write this as tan inverse of 5x minus x over 1 plus 5x square. That is nothing but tan inverse 5x minus tan inverse x. Write this as, what you should do is divide by 3. So this becomes 2 by 3. This is x. This is 1 minus 2 by 3. This is tan inverse 2 by 3 minus tan inverse x. These two will cancel. This is a constant. Therefore, answer is 3y by x is equal to 5 over 1 plus 25x. This is the fastest way of doing it. Divide by 3 here only in the book. So tan inverse of 2. So that formula you should remember. Tan inverse of x plus y over 1 minus xy is tan inverse x plus tan inverse y. The minus sign is there. You can do it like. Next problem. Y is equal to 1 plus x plus x square over 2 factorial plus x cube over 3 factorial plus etc. x to the power of n over n factorial. Here I would like to write the list of answers given. Then dy by dx equals. What are the answers given? I want to list the answer because the answer will not be in the format that you get a solution. You need to think one step ahead. 1 by y. Third answer is minus y. Fourth answer is minus 1 by y. So you should remember this is nothing but e to the power of x. The expansion of exponential series. So what is dy by dx? It is e to the power of x. But answer is not there. But what is e to the power of that is y. Therefore, this time. It will not take more than 40 seconds if you are aware that this is e to the power of x and answer. Otherwise, student will get e to the power of x and then start thinking that answer is not there. But what is e to the power of x is y. That's one of the reason I keep mentioning what the previous years. But this knowledge might help you somewhere else. We don't know. The next one, if 27 AMI square is only to test your ability in simplification equals 4 into a minus 2x whole cube. Find dy by dx. Find dy by dx. So here, this is 27 into 2a y dy by dx is equal to 4 into 3 a minus 2x whole square into minus 1. 4 is a constant. This is 3 into this minus 2. They are written like this. cancellation becomes easy for me. These two also get cancelled. So what is dy by dx? Dy by dx is equal to 4 into a minus 2x whole square divided by 9ay. That's the answer given also. So you should cancel it very fast and write the answer. First thing is you should use chain rule for this. In simplification, you should be able to, these things you should learn. The moment I saw 2, oh, I am getting one more 2, let me cancel that. Let us take the next problem. The derivative of root sin x with respect to root cos. Again, a parametric function. You can call this as y, call that as z. You have to find dy by dz. What is dy by dz? First differentiate this 1 over 2 root cos x into minus sin x. Differentiate this 1 over 2 root, the 2 root sin x will come to the numerator and cos x will come here. So what do you get? 2 and 2 cancels. It is minus tan x into root tan x or minus tan x to the power of dy. This is a method. Instead of dividing, division is nothing but reciprocal multiplication. Put that properly, you get a solution. These are the skills you should develop. Once you start practicing, automatically you get this thing. The next problem. Y is equal to sin 6x cos 4x. What's the method? You can use product rule. No. The answer is not given in the format. And you should, the moment you see this, you should recall this formula. What is sin A cos B? It is half of sin of A plus B. You have no time to write the formula there, but I am writing it here just to remind you. All these formulas should be in your mind. So y is equal to half of A plus B is sin 10x. A minus B is sin 2x. So what is the answer? Dy by dx is equal to 5 sin 10, 5 cos 10x plus cos 2x. Because 2 and 2 cancels, and cancellation you should do mentally. Don't start writing 1 by 2 into 10 into and all that. Is the answer given? Next. The next problem. So I am working more problems here because the only thinking is when you work more problems, concept becomes very clear. Try to work these problems again. What's the method I have told you? Copy all the problems in separate sheet of paper and start working. Of course, when you are working at home, you may take more time. No matter, because you are understanding the concept. Once the concept is clear, the speed automatically comes. The next problem, if y is equal to 3 cos 2x, 3 cos 2x plus 4 sin 2x, then d square by dx square. The moment you see, recall that y is equal to a cos mx plus b sin mx, d square by dx square m square y. If you can remember. All the time you can't remember, no matter, you can work it out first. Dy by dx is equal to This is 6 minus 6 sin 2x. This is plus 8 cos 2x. First differentiation. Then d square y by dx square is equal to minus 12 cos 2x minus 16 sin 2x. So you want written 3 here and 4 here. Therefore take minus 4 common. So 3 cos 2x plus 4, 3 cos 2x plus 4 sin 2x. So minus 4y. So what was the method I suggested? If y is equal to a cos mx plus b sin mx, d square y by dx square is equal to minus m square y. What is m is 2, so minus 4y. If you can realize this, because while working so many, it automatically should come to your mind. If it is not possible, try to work it out first. But you should realize they worked a similar problem. You may not be able to recollect the answer, no matter, but try to work fast. The next one, y is equal to tan inverse of x over root of a square minus x square. These sets of problem, moment you see a square minus x square, put x is equal to a sin theta. So what do you get? Tan inverse of a sin theta over a cos theta, that is equal to theta. Theta is sin inverse x by a. Therefore dy by dx is equal to 1 over root of a square minus x square. Easy flow should be there. You can even review some of the steps also. But this is the method. The moment you see a square minus x square, you get tan inverse of tan. Don't write tan theta and all that. That is what we do in regular examination. The moment you get this, it is theta is sin inverse x by a. And different sin inverse x by a also you should remember. 1 over root of a square minus x square. If the formulas are in your fingertips, working CET problems are going to be very, very easy. Let's go to the next problem. If x to the power of m into y to the power of n is equal to a plus b to the power of m plus n. We have worked a similar problem. The class x to the power of m into y to the power of m is equal to x plus y to the power of a plus m plus n. That problem is different from this because a plus b is a constant. So what is that we should do? This is mx to the power of m minus 1 into y to the power of n plus nx to the power of m into y to the power of n minus 1 and dy by dx is equal to 0. Now what is it you have? You can cancel, you cannot cancel anything. Dy by dx is equal to minus of m into x to the power of m minus 1 into y to the power of n divided by n into x to the power of m into y to the power of n minus 1. Here this will cancel, x will remain. Here this will cancel, y will remain. So minus m y, n will cancel, my by nx. But you should realize it's a constant, therefore it is 0. The next problem. If x is equal to a into theta minus sin theta, y is equal to a into 1 minus cos theta. Parametric problem. Then dy by dx. What is the first step? Cancel a. Dy by dx is equal to, it is just sin theta. because 1 is 0, cos theta is minus sin theta, minus cos. This is 1 plus cos, 1 minus sin theta. That is 1 minus cos theta. That will get the answer 2 sin theta by 2, cos theta by 2. This is 2 sin square theta by 2. 2 and 2 cancel, 1 sin cancel. So you get cot theta by 2. Now, would I given 4 answer tan theta by 2, cot theta by 2? You have to take the right answer. Let's go to the next problem. If y is equal to log of 2 over 1 plus cos x, you have to find what is dy by dx. Then dy by dx equals. See, you should remember always 1 plus cos x is 2 cos square x by 2. 1 minus cos x is 2 sin square x by 2. So this is going to be log of secant square x by 2. You know why? 2 over 2 cos square x by 2. 2 and 2 cancel, secant square x by 2. That is equal to, y is equal to 2 log secant x by 2. So dy by dx is equal to 2 into 1 over secant x by 2 into secant x by 2 into tan x by 2 into 1 by 2. See, I am using the formula log m square is equal to n log m. So differentiation becomes easy. 2 is keep it here. Log is 1 over. Secant is secant x by tan x by 2. X by 2 is 1 by 2. All this will cancel. The answer is tan x by 2. So these problems are given just to test your ability in simplification plus the knowledge of differentiation. Let's go further. If root of x plus y, if root of x plus y plus root of y minus x is equal to root 2, then there was b square y by dx. Very interesting. B square y by dx. The problems look difficult, but if you have worked it out earlier, then it will be easy for you. Square both sides. You are using a plus b also formula. A square plus 2ab plus b square is equal to a plus b was a square plus 2ab plus b square. X and x cancels. This is 2y is there, 2 is there, so you can remove that 2. So y minus 1 is equal to minus root of y square minus x square. Here 2 is, all 2 will go. Square both sides. Y square minus 2y plus 1 is equal to y square minus x square. Y square and y square cancels. So differentiate. Minus 2 dy by dx is equal to minus 2x. So dy by dx is equal to minus x is answer. No, plus x. Because both sides you got minus. Let's go to the next problem. Y is equal to log x to base 10. So you should see the base. If it is log x to base e, the answer would have been easy. So first what you should do is you convert this. log e to base 10 into log x. So dy by dx is equal to log e to base 10 by x. See, the formula that we are using is log m to base n is log m by log n. Similarly, when you have got log x to base 10, it is log x to base e divided by log 10 to base e. Normally, they bring that in numerator just to confuse you. So this is a constant, keep it as in log x 1 by x. Let's go to the next problem. Y is equal to sine of 2 sine inverse x. See, if the sine of sine inverse x, it is x. The moment they give 2 here, it's confusing. So what is the method for this? Write this as 2 sine inverse x is equal to sine inverse y. Differentiate. This is 2 over root of 1 minus x square is equal to 1 over root of 1 minus y square into dy by dx. So what is dy by dx is equal to, this will go up 2 into root of 1 minus y square and root of 1 minus. The next problem. If tan inverse of half y is equal to root of 1 minus x or 1 plus x. Seems, then find dy by dx. So what is the method? You first write this as half y is equal to tan of, and for here inverse is not there, it becomes inverse here. Tan inverse of 1 minus x or 1 plus x. This is a standard problem. You should remember, you are putting x is equal to cos 2 theta. Why cos 2 theta? Can avoid half angle. So half y is equal to tan inverse of, so 1 minus cos 2 is 2 sin square theta, and this is 2 cos square theta. So half y is equal to theta. But what is theta? Theta is half cos inverse x. Half and half will cancel. So dy by dx is equal to minus 1 over root of 1. See whether it is clear to you. The reason they have given half so they can cancel it. Don't put all the substitution. Even this also not necessary. You can just imagine tan inverse. X is cos 2 theta. 1 plus 1 minus cos 2 is 2 sin square theta. Sin by cos is tan. Tan inverse of tan is theta. What is theta? Cos inverse x. So differentiate cos inverse x. Get a solution. I think with this, we'll close the class today. Tomorrow, I will just first start with the integration, then come to application. Yesterday only I thought I'll wind up the differentiation class and go for integration. Then I got a second thought. Let me work some more problems so that the concept becomes very clear. I think the problems that you worked today has made you go a little more deep into the concept of differentiation. When you work all these problems, you start thinking a little more deep into the subject. You understand the intricacies of differentiation. That's what I just think. About 25 problems, more than that I have worked. These problems will certainly help you to improve your capacity or the competency level of the differentiation. So with this standard, we'll move on to integration tomorrow. I'm going to remind you, we need all the formulas, and there's no time for me to list all the formulas. But if you look at my previous classes, when I did my revision for the second principal examination, I've listed all the formulas. So look into that, and with that we can just continue with integration tomorrow. So thank you. Good night.